So students, today in this video we will discuss the concepts from current electricity. There is drift velocity we will discuss, mobility, current density, all these concepts we will discuss. So drift velocity, first of all we will discuss. It's a velocity, average velocity that an electron moves in a conductor opposite to the electric field provided. Because it's a negative charge field, suppose is away from the positive charge, then electron will be moving against the field. So we'll derive the expression for the drift velocity. So as I told you, suppose this is a conductor and electrons, they will move in a zigzag path. They will not move in a straight line. So they will not move in a straight line. Instead, they will move in a zigzag path. They will collide with other electrons and the nucleus. So they will move, they will start from, let's say, rest in randomly in any direction, then they will collide with any of the core or electron, then they will change their path and they will move freely for some time. Again they will collide on their path with another electron. So like that they will move zigzag path, right? They will move in a zigzag path. They will move in a zigzag path. So we will find out their average velocity, because they will start after the collision. Of course, when their speed will become zero, again the speed will increase up to a certain speed, then they will collide. So this velocity's average velocity will calculate, that is called the drift velocity. So let's say the Vi, that is the ith particle velocity after the collision, is, let's say, ui plus a ti, acceleration ti. So what we will write acceleration, because a electric field is provided, electrons are drifting towards in this direction. So a electric field is provided, that means acceleration, we know that's force upon mass, and F is QE. We know the relationship between force and field, so F is QE. So we can write QE. Q is here our charge is electron, so Q we can write EE by M. Of course minus we can write, but magnitude if we want to write acceleration, so only it's EE upon M. This is acceleration. So if we want to average out all these velocities and of all the electrons, so of course and divided, so it will not be a problem. So if we average out, this average of all velocity will give us drift velocity. Average of velocity is the drift velocity. So we'll average it out. This is also average. This time also will average it out. Time is the collision time. Suppose from here to here the time it is taking, right? Then it is colliding. So this is the also called relaxation time. This is called relaxation time, Ti average, the average time of collision, that will be called relaxation time. Relaxation time, right? So this is relaxation time. We'll write tau, and this random direction, initial velocity, random direction it will be. So average of all the random direction, this direction initially. So initial velocity, random direction, it will be approximately, the average will be 0. So it will be, your velocity is only at, okay, and Ti is the Ti means, suppose from here the electron is there and after that it collided, so let's say this time is T1. After T1, the T1 time the collision happens. Now from here to here again comes, it's, let's say, T2. So all this average is your Ti, ith particle, all average. Now if we take n particles also, the average n will cancel out, because n times you will add all the particles divided by n, so it will be cancelled out. You will get the same expression basically. So if you take all atoms, all the electrons, then also your Vd will come up as A is your this one, that is minus EE by M, and this is tau. If we take the magnitude, it is EE it will be, if we take magnitude of the velocity, okay, so it will be E by m tau. So this is your drift velocity of the electron. This is the drift velocity of the electron, the concept of drift velocity. Now drift velocity per unit electric field, that is called mobility. The concept of mobility. What is mobility? It's the movement per unit electric field. What is the speed it is moving? So drift velocity per unit electric field, magnitude you can take both. This is called mobility, a mu symbol or some other symbol also used. So this is called mobility, drift velocity per unit electric field. So drift velocity is this one, E magnitude by, you can take this magnitude, E m tau by E magnitude. This is also magnitude, cancelled. So you are getting E tau by m. So this is your mobility, E tau by m. This is the relaxation time, not torque, right? This is relaxation time here. Now we will derive an expression in terms of current density, and from there we will come into the concept of resistivity and conductivity. So let us say this is the conductor and its length is L, area of cross section is A, right? So it will have a volume. Volume will be A into L. What will be the volume of this conductor? Area of cross section into length, right? So volume will be AL. Now let's say the number density, N is the number density, which is number of free electrons per unit volume. N is equal to, let's say, density, number of electron per unit volume. So for V volume, what will be the number? How many numbers of electrons will be there? Now for V volume, the number of electrons, total number of electrons will be, number of electrons for V volume will be N into AL. And total charge inside this volume V, what will be the charge? Total charge inside this volume V, and total charge is, because each electron carries a charge E, so what will be the charge? This much of volume, this is the number of electron, so total charge will be NaLe. This is the total charge, or Q you can say. Okay, this is the total charge, NaLe. Now we are interested to calculate the current in this conductor. So current is basically your Q by T, and if it is having length L, so how much time it will take? Because the electron is moving with a velocity, drift velocity Vd, and L is the length. So how much time it will take? The time will be distance by speed. Speed is your Vd, so distance is L length, speed is Vd, so your time will be L by Vd. So if we will replace this equation, Q is your NaLe divided by E. We are writing the magnitude of the electrons, sign, negative sign, minus we are not writing. So T is your L by Vd, LL cancelled. So your I you are getting, current you are getting, Vd will go to the numerator, Na or NEA Vd. This is the expression for current. Clear? So from here you can find out, this is the current flowing. So from here you can find the current density. Current density is I by A. The concept of current density is I by A. So I, if I divide A, I by A is NE Vd. This is your I by A, or this is J. Current density, J is a vector, you can take magnitude. So this is N E, and Vd is what? Drift velocity over this one, E by m tau. So E by m tau magnitude. Okay, so this is your J equal to this one. Now you can write J equal to n e square, right? N e square and E magnitude by m or tau here, or m, this n e square tau by m, J equal to n e square tau by m e magnitude. Now we know a relationship between J and E from Ohm's law. What is the relationship we know? Now from Ohm's law we know that B equal to IR and R is rho L by A. So we can write rho L by A, and V equal to, you know, EL. So it's rho L by A I, and LL cancelled, I by A is J. So you are getting basically E equal to rho J, E equal to rho J, or J equal to 1 by rho, that is your sigma, or you can write 1 by rho, that is sigma E equal to conductivity rho E equal to J. This is the relationship between J and E. J equal to sigma E, conductivity E is J. So J equal to sigma E. So if you compare this equation, if you compare this expression and this expression, okay, let's say 1 and this is 2. Let's say compare 1 and 2. So this part will be definitely sigma conductivity. Current density is, and it's a vector. How? Because area we are dividing current. So current is there, current no direction. We are not considering it's a vector. So area is a vector, so dividing vector. So we are writing J is a, current is a vector. J direction is same as the field direction. So this is your sigma. So conductivity will be n e square tau by m, or resistivity is equal to 1 by conductivity. So just reciprocal, that is m by n e square tau. That is your rho, resistivity, and this is conductivity. Resistivity unit, you know, ohm meter. So this is the whole discussion about your conductivity and resistivity, mobility, the relationship between drift velocity and current. So all these things we have discussed in this video, and very important question comes in the many of the entrance examination. One more concept I think it will be better if we will discuss, that is the graph of resistivity versus the temperature, because with the increment of temperature the randomness of molecules increase. So briefly let me just discuss the graph of resistivity versus temperature for conductor and semiconductor. Both the graph let me discuss. So the resistivity versus temperature graph for conductor or copper, like this of element. So conductor, it will be like this. This will be the, means with the temperature, increment of temperature, resistivity will increase. More opposition will comes and resistivity will increase. This is for conductor. For semiconductor, the graph will be, it will be decreasing. The resistivity will decrease with temperature. For semiconductor means like silicon, germanium. These are the semiconductor. So semiconductors, the graph is, rho is decreasing, resistivity is decreasing with temperature. Now look at the expression of your resistivity. For conductor, what happens? The current density, the number of the number density, the charge density, number of charge per unit volume. Okay, n is the number of charge per unit volume. So it remains almost constant, because free electron available in your conductor is almost same even if the temperature increasing for conductor. So n will approximately remain constant for conductor, and the relaxation time, because the temperature is increasing, so the electron will come across more collision more and more. That means the relaxation time, the average time of collision will decrease, right? because more and more collision, because randomness will increase, so more faster they will collide. The time that collision time will reduce, right? So average also will reduce. So average will reduce. That means rho will increase. Resistivity will increase. So temperature increases in a conductor, resistivity increases. Resistivity increases. Now for semiconductor, what happens for a semiconductor? The resistivity decreases, temperature increases. So you will ask that why? What is happening for the semiconductor? A semiconductor, as the temperature increases, N also increases. The free electron, number of electrons in a per unit volume is increasing. It increases for semiconductor because more number of electrons comes from the comes to the valence shell, or they come out from the cell and becomes free with the increment of temperature. So N increases and increases more than the, of course the relaxation time decreases because there will be more collision, but whatever the tau increase as compared to tau, N more increases more. So in the denominator as a whole increases, so rho decreases. Denominator as a whole, because N increases more and more as compared to your tau, relaxation time. So as a whole resistivity decreases. Okay, so this quantity, the whole quantity as a whole goes up, so resistivity will go down. So that happens in a semiconductor graph. So this is the explanation for your graph of resistivity versus temperature in case of semiconductors like silicon, germanium, and conductors like copper. Okay, so these are the graphs and these are the equations. So you go through it. Any doubt, any confusion, you ask me in the comment. So I'll try to clarify your doubts in the next videos. Thank you for watching. See you in the next video.